So hello everyone, welcome to BISP Solutions. So in this video, we are going to see linear regression on sales data order data from Fusion. So basically, we are going to bring the data from the Fusion and we are going to apply the real linear regression on that and see the output. So let's move ahead and see what is linear regression. So linear regression is a statistical method used to model the relationship between a dependent variable, also known as the target variable or response variable, and one or more independent variable, also known as predictor or features. The objective of linear regression is to find the best fitting linear equation that describes the relationship. Equation for a simple linear regression is y is equal to beta 0 plus beta 1 x, where y is a dependent variable and x is a independent variable, and beta 0 is the interceptor and beta 1 is the slope. Now let's move to our instance and Oracle instance, and let's see how we created the uh, report. So here we have taken the order date, product, order ID, purchase address, transaction line quantity invoiced, price each, sales, revenue, and expenses. So this is the head. And if we go to results, this is the result. And if you go to here, export data and CSV, and you have to export that into the CSV. So I have already downloaded the CSV file. If sales 2, if we open that, so this is our data and we will use it for the linear regression. Now let's jump onto our code. Okay, so this is the code, and on the top left right hand corner, if you see, this is our plots. So now let's break the code and let's try to understand the code line by line. Okay, so first what we did, we imported all the libraries. So first we imported pandas and numpy, which are used for data manipulation and numerical operation. Then we imported a seaborn and matplotlib, which is used for data and data visualization. And then there is warning. It is used to suppress any warning during execution. Okay, so let me just uh, comment it. So the first is libraries. Okay, so first we imported libraries. Then what we are going to do? Then we have filtered warnings. We are going to ignore all the warnings. Then this here, what we did is reading data. So here we used Panda library to, and in that we used read underscore CSV function to get our CSV file. And if I remove these, so this is going to provide us the train.head. Okay. So first we got the CSV file and we have stored it in a variable called train. And in the next line we see is train.head, which will show you 5 rows and the number of columns. So just we'll run this code. So I'll press shift and enter. Okay, so it is showing us result of 5 rows and 9 columns. Okay, now let's apply a few. Okay, after that we are going to pre-process the data. So let's data. Okay, comment it, data pre-processing. Okay, first let's just copy this data onto a variable, and let's name the variable as train original. Okay, and we are going to copy all the data from the train variable to this variable, and for that we are going to use a function called copy. Let me click on save. Before that we actually, okay, so yeah, after this we are going to do data pre-processing. Let's copy again train underscore original, and this is going to be equal to train dot copy. So this will copy all the data from the train data frame to the original train underscore original data variable. Let me remove this code. Okay, first we are going to get the column. So our train dot columns is going to display all the column name. Let's just run this, shift enter. Okay, so here on the console, if you see index, inside that you see the all the column names. So order date, product, order ID, purchase address, transaction line, quantity, invoice, price, each, sales, revenue, expense. So these are all the columns we have. Let's just do another operation, which is shape, which will give you the number of row and columns. So inside parentheses on the left is the number of rows, and on the right there is number of columns. So we have 75,000 rows and 9 columns. Now let's see the data type. So if you see train.d type, so this is going to show the data type of each column. So remember, it is going to provide the data type of each column. Let me click on shift and enter. And here you can see order date, the data type is object, product data type is object, order ID, the data type is integer, and purchase address, the data type is object, and transaction line, quantity, invoice, price, each, sales, revenue, expense, all are float. Okay, now let me again print back my code, and we'll do is now we are going to do one hot encoding. So one hot encoding. Okay, so this pd dot get dummies train data type integer. What it is going to do, this is one hot encodes categorical variable in the data frame train to convert them into a format suitable for machine learning. So this is going to convert this uh, get dummies. So this is going to convert our data frame into a format suitable for machine learning. Okay. Now what we are going to do. Okay. In this step, we are actually defining features and target. So now we are going to define the features and target. So this X and Y. So X contains the feature values. So we can say independent variables. So uh, this contain independent variables, and the Y contains target variable. So this is dependent variable. Dependent variable. Okay, let me remove this code and let's see the output of X and Y. Okay, so it has fetched us all the columns, sorry, the independent variables. So on the top, if you see, is independent variables, and if you scroll down, these these are dependent variables. Okay, now let me bring back my code, and this line x is equal to x dot drop any. So this is going to drop any n values in our data frame. And now after this, we are going to split data into training and testing set. After this, we are going to convert, we are going to split data into training and testing set. So here, if I remove this code and you see from sk.learn model section, this is library. This is library scikit-learn library, and from that we are going to import train test split function. For that, we have taken four variables, which is xtrain, xtest, uh, ytrain, and ytest. And we are going to split the data set into training and testing sets using 92% training and 8% testing split ratio. So here you see test size is 0.08 and random state S51 sets the random seeds for reproducibility. Okay, so let me run this and let's see the output. So this is our output. So these are the uh, training set and testing sets. Now just okay. Now we are going to build and train the linear regression model. Okay. After splitting data into training and testing set, we are going to build and train the linear regression. So first we this creates okay. So if you see this line of code, let me remove this. Okay. If you see this line of code, so from the scikit-learning library, we have imported linear regression and we have assigned this linear regression to a LR variable. After that, uh, we have fit it into training data set, which is X train and Y train. Now let's just run this and okay, so the model score is 0.999270 and it goes on. So our model is 99% accurate. Okay, and okay, and after that, okay, so here you see LR dot score. So this computes R squared score of the model on the test data, indicating how well the model fits the test data. After that, we are going to do is prediction and visualization. So, okay. So here you see y underscore pred as a variable which contains predicted value for revenue. Okay. So this is dependent variable revenue we took. So this contains the predicted value of revenue based on X test and pred underscore df which creates a data frame comparing the actual and predicted values. So actual value is y test and predicted value is y predicted. And the difference, okay, so this is the actual linear regression algorithm we have used. Let me remove this code and let's print our linear regression. So this is we are getting the model score is this much and actual and predicted value and the difference for each row. Okay, so since we used drop NA, the number of rows has been reduced. So the number of NaN values which contains in the row has been removed. Okay, now we are going to plot a graph. Okay, so this is going to create a regression plot to visualize the relationship between actual and predicted values. Okay, so this is coming from Seaborn library. So SNS dot regression plot, which says REG plot, and we have provided X and Y. So what comes under X is under Y underscore test, and on the Y axis, which what comes is the Y underscore pred uh, or Y prediction, and the scattered KWS is blue and line KWS is red. So we have made the line in red and the scattered KWS, which is blue. So these dots, if you see, these are scattered KWS, and we have labeled x-axis as actual value, and we have labeled y-axis as predicted value. After that, we have uh, provided the title for the graph as actual versus predicted values, and finally we have shown the graph. Okay, so let me delete this graph and let's just try to run this. Okay, run this code and let's see if we are getting same output or not. So I click on shift and enter. Okay, so we have got our graph, and yeah, that we have achieved a straight line, and which is passing through the dots, and yeah, we have achieved our regression. So that's all for this video. Thank you for watching this video. We'll meet in the next video with some more cases. Thank you.